Hi everyone. I have just 5 minutes to tell you a story of something that was generated over the past 5 years. So let's get started. This is a story of how we generated lead-like libraries from three-dimensional fragments. It starts with LCC, a chemistry-based CRO with a plethora of chemical technologies that give access to three-dimensional chemical space. The space is highly functionalized with a variety of synthetic handles, is sp3 and 3D rich, and stereo defined. We wanted to take this scaffold fragment space and use it to design and virtually synthesize a lead-like library via decoration of our proprietary 3D scaffold collection. In order to do this, we were going to focus on three key design parameters: quality, diversity, and novelty. The quality was going to come with a focus on rule of 4 lead-like chemical space. It was going to come from a high synthetic success rate that comes from using known and validated scaffolds with robust chemical transformations. The diversity was going to come from the widespread of sp2, sp3 character and molecular weight inherent to the scaffolds. We needed a partner to help us with diversity controlled reagent selection when we go from the 1,000 fragments to the 5 million lead-like molecules. And novelty was an important consideration also. It's inherently instilled by the proprietary scaffold selection, but we also wanted to find a better way of ensuring the maximum novelty upon enumeration of the proprietary scaffolds. So in order to do this, we needed more than our chemistry expertise. We needed world-leading computational expertise, and this came in the form of cressit. So why did we choose cressit? The key for me, there are many reasons, but it was to ensure that we retained all of that excellent knowledge of the three-dimensional conformation and conformational sampling of these 3D rich small molecules. And cressit has a wide range of tools used in library generation. So the library process that we were going to go on was taking the scaffold and reagent chemical space, using cressit's picker tool that can cluster and select in 3D shape and electrostatic space to select the scaffolds and reagents that would instill the highest novelty, synthetic tractability, and good property space. The picker will then allow us to cluster and select representative examples so that we can effectively sample the 3D chemical space. Using picker was highly important because this is an example of where 2D and 3D space are not always portrayed to be the same. So you have an example here in the bottom left of two boronic acids that we can clearly see from the 2D image should be similar in 2D space, but are widely diverse when calculated in 3D space. Moving on to the scaffold selection, it was very apparent that we had a high percentage of scaffolds all possessing the same secondary amine synthetic handle. So this would be an excellent place for us to base our enumeration upon, because the secondary amines are prevalent in all the scaffolds and are very versatile and robust reagents in the coupling chemistries. So here we have the 5 examples of different chemical transformations we selected for the coupling and enumeration chemistries. So you can see the acylation, alkylation, SNAR, sulfonamide formation, and urea formation. And just quickly looking at these structures, you can see from the 3D conformations just how diverse and three-dimensional the structures are. Looking at the library properties, we've successfully entered lead-like chemical space, average molecular weight of 370, but a good distribution across the range. The color coding is for the different molecules based on the different transformations with the different reagent sets. We have good total polar surface area with an average of 70, but again with a good range. The C log P average of 3, with most of the molecules between 0 and 4. An excellent QED score for drug likeness, and a fraction sp3 right in the sweet spot of 0.5, with most of the compounds between 0.3 and 0.7. This slide is very interesting. The PMI analysis shows that our library has a distinct uniqueness of rod, predominantly rod, but with some spherical character, as opposed to the traditional examples of approved drugs you can see in the smaller image, which will tend to stick down the rod disc sphere. But this is no surprise due to the high sp3 character of the scaffolds we were using. And the NPR versus PBF analysis was very pleasing because this shows that 90% of the library is above the cutoff, which means there is again proof of high degrees of three-dimensionality in the library molecules. When it comes to the applications of this library, they are multiple. Virtual screening and hit validation is the obvious one. So identification of virtual hits and synthesis of these hits on demand. We can also think to use this for HTS screening. If you already have an existing HTS collection, we could do analysis either yourselves or with cressit to identify the gaps in your current library that this collection could fill. Similarly, for phenotypic screening, diversity is the name of the game, and good property space. You don't know the structure of your target, but this is a highly diverse drug-like novel library that you could effectively use in phenotypic screening on synthesis of physical samples. And if we take this back to the scaffolds themselves, there is an alternative use of these scaffolds. Rather than taking the secondary amines and putting on additional building blocks to make lead-like space, we could instead attach covalent warheads to the secondary amines for covalent fragment screening. So in summary, the combination of LCC's synthetic expertise and Cressit's computational expertise has enabled the creation of a lead-like virtual library that is all of the things we want it to be: drug-like, novel, diverse, 3D rich, enantiomerically pure, and rapidly accessible to robust chemical transformations with commercial reagents. I'd like to thank the entire LCC and Cressit team that joined forces to deliver this quality product. And if you'd like access for the full presentation and the 5 million 3D structures, please contact us at these details. Thank you very much and have a great conference.